All right. So, here's the situation. The Soto family is rafting on the Colorado River. Suppose that they are on a stretch of the river that is 150 meters wide. Okay? So if this is my river, we got 150 meters is how wide that river is at that point. It's flowing south at a rate of 1 meter per second. So it's flowing south at 1 meter per second. And in still water, their raft travels 5 meters per second. So what they're basically saying is if there was no current whatsoever, if you're sitting in a pond or a lake or whatever, what they're saying is they can make their raft go at a rate of 5 meters per second. Okay? So if we say we're starting here and we're trying to go across, all right, if it were still water, we can go at 5 meters per second. Okay, that's the rate, or that's the force that they can put into this raft to begin trying to get across the river. Okay, so there's our situation. Okay, part A says, how long does it take them to travel from one bank to the other if they head for a point directly across the river? Okay. So A says, how long to cross the river, okay? If they try, they're always paddling or whatever they're doing, they're always trying to go directly across the river. How long will it take them? Okay? This question confuses people quite often. Okay? What do you think the answer is, or how you get your answer?
It'd be around 30 seconds.
150 divided by 5?
It'd be around 30 seconds.
Around 30 seconds?
It'd be exactly. It'd be close.
You don't think it'd be exactly? Why?
Because you have 1 meter per second down, so you're not going to be able to travel 5 meters per second across.
What do you guys think about that statement?
Yeah, I think it's right because you're going at an angle, not straight across.
You're going to travel a farther distance.
How far across are you getting, though, every second?
5 miles.
You will travel more than 5 meters per second, but how far horizontally are you traveling every second? Because if you go, yes, you guys are correct. You're trying to go 5 meters per second this way. Well, the current's going to push you 1 meter per second this way. So this is how far you end up traveling in a second, correct?
It's 26.
Okay? So you travel more, yeah. You travel more than 5 meters in that second. But you're thinking too much at an angle, okay? Even though you're right here, how far have you gone horizontally across the river? 5 meters. Horizontally, you've gone 5 meters. How far, though, have you traveled? The square root of 26 meters. So a little more than 5 meters. But that doesn't matter, because it wants to know how long does it take you to get to the other side of the river. So in 1 second, you've made it 5 meters across. In another second, you'll be another 5 meters across. Yeah, you're going to end up downstream, I agree. But every second, you are going exactly 5 meters across, even though you're going more than 5 meters distance. You got to think the difference versus how far you're actually traveling versus how far across the river you're traveling. So the answer is simply 150 divided by 5, or 30 seconds.
Wait. But I thought you're traveling like 5 point, like 1 or something.
That's the distance you're traveling, yes. But how far across the river have you made it?
Oh, 5.
How far horizontally have you made it?
5.
5 meters. In the next second, how far horizontally will you have made it?
10 meters.
Mm-hmm.
Okay.
So So you're still going horizontally 5 meters every second.
Alright.
You got to think about it horizontally. Even though the total distance you've traveled each second is more than 5 meters, but you're traveling that at an angle,
Yep.
right? Okay. So how long does it take to get across the river? Still 30 seconds. Okay? Part B. How far downriver will a raft land? So how far downstream will you end up?
Let me square root of 26 times 30.
Okay.
You'll end up 30 meters downstream.
Won't you just,
Square root of
wouldn't it
26
just
times
be,
30. Well, because if you found for
Yeah,
1
it'd be
second,
100 wouldn't it just be
because
150
you found for
meters
1
down?
second,
Because you can get across the river in 30 seconds and you go a meter down every time. So it's 30
Why is it
Yeah,
150?
it'd be
Because it's like, it's like,
I was finding total distance.
Yeah. Yep, you were finding total distance. How long does it take you to get across? 30 seconds. Every second you travel, how far is the current pushing you downstream?
1 meter.
1 meter. If you're being pushed downstream 1 meter every second, and it took you 30 seconds to get across the river, you will have been pushed 30 meters downstream. Basically, if I drew my river wide enough, couldn't I create basically 30 of these right triangles to get all the way across if I drew it to scale? Okay? So yeah, for part B, okay, 30 seconds times 1 meter per second will equal 30 meters downstream. Okay. Now, finally, the very last question. What is the velocity of your raft with respect to the shore? So how fast do you actually end up traveling? What will you need to figure out to determine your actual velocity of the raft as you travel?
Oh, like the hypotenuse.
You'll find the hypotenuse. Yeah. You'll find the resultant. Okay. 5 squared plus 1 squared, so square root of 26, about 5.1. Is that what it was?
5.099.
Okay, so Pythagorean theorem, you get 5.1. How would I label it? Meters per second, yeah. And I did Pythagorean theorem to get that. So with respect to the shore, with respect to where you started, yes, you traveled 5.1 meters in a second. Okay? You traveled 5.1 meters in a second. Even though you don't end up going exactly across, you get pushed downstream. If you aim across and there's a current against you, you're going to obviously get pushed downstream. Okay? Now I'm going to add one more thing to this. Okay, and this is the part I like the best here. Okay? What would you have to do to go directly across the river?
Find the angle.
Just aim 30 meters up.
Well, is it 30 or not?
You would have to swim at an 11-degree angle upstream.
You're on the right track and you got to aim upstream, right?
But that wouldn't be going straight across.
Your
Would it
result,
end at the same point that you started at?
your resultant could be yes. If you
You'd have to aim for 30.
aim, so I see what you're saying. So I want this, I want that to be my resultant, correct? In order for that to be my resultant, you guys were correct. You got to aim upstream a little bit, right? So we're going to aim upstream. How fast can we paddle this raft? 5 meters per second. So that would go here. Because that's what we're going to try and do. We're going to try, we know we can travel 5 meters per second in still water, so we're going to take that same pace, but we're just going to aim upstream a little bit. But while we're aiming upstream, what else is acting on us? The current, which is pushing us
Down.
at what?
1 meter.
1 meter per second. Okay? So we try to do this while the current's doing this, so therefore this is our result. Okay? So this would be the picture.
Are you trying
Wouldn't
to
you actually
find-
travel slower?
Yeah, because when we find this answer right here, won't it be smaller than 5?
That makes sense.
Because 5 is our hypotenuse now, right?
Yeah.
Okay, and yes, that would make sense. We should be traveling slower because we're fighting that current just a little bit when we aim upstream. Okay, so 5 squared minus 1 squared, square root of 24, I'm assuming that's 4.9, maybe 4.85, I'm guessing, square root of 24.
4.898.
So 4.9, probably a pretty good estimate. Okay,
97.
so about 4.9 meters per second.
I thought the question was asking how far you want to swim upstream.
No, not how far. No, because
Like degree-wise.
oh, well, then we're going to figure that out next too, yeah. So, we end up traveling at 4.9 meters per second, but yes, my true question is, what should we set our heading at? What direction should we try to go if I want my resultant to be directly across the river? Derek?
11.5.
11.5 degrees. Can you explain what you did to get that?
I did inverse tangent of 1 and then 4.8.
So he did the inverse tangent of 1 over that entire decimal?
Yep.
Okay, Drew?
When you want to do the inverse sign probably before that, just because you have the exact number.
Yeah, so you don't have to use that decimal in this case. Yeah, you could have used inverse sign, but if you used all the decimals, that's still going to give you the same answer. But I would have done, in this case, I would have done inverse sign because you know the opposite, you know the hypotenuse, they're nice numbers. So inverse sign of 1 over 5, you get your answer of 11.5 degrees.
We got the exact.
So basically you want to aim the raft 11.5 degrees, if we're assuming this is north, south, east, west. You want to aim the raft 11.5 degrees north of east to go directly across the river. Okay? Would that have been the same as the angle back in this one?
No. Because that one was, I did that, that one was like 11 points.
This one's going to be different because here it is. If we did solve for this angle, you do the inverse tangent of 1 over 5. Where in this picture, you did the inverse sine of 1 over 5. So you will get
too long.
you'll get some different answers. They're not going to be far off, okay, because if you look, this would be the inverse tangent of 1 over almost 5, but not quite. So they're going to be very close to one another, but they're not going to be exactly, okay? This one a little,
Bigger.
this one was, this angle
Well,
was,
it's like 5, the other one was like a little bit.
okay, so, alright? So, I really like this question. You got to think about a lot of different things, and you got to think about the different lengths of time it would take to get across. I also really like this part of it. At what angle would you need to start your raft or aim your boat in order to go directly across when you're fighting that current a little bit? Notice the differences in the pictures. Okay? In the other one, we just aimed our boat directly across the river, so that's where I drew my 5 meters per second. In this one, I want my resultant to be straight across the river, so I better aim my 5 meters per second upstream a little bit. So you understand the difference between the two pictures. Okay? Any questions on that problem? Okay? So there's a good river problem. You'll see something like that for sure. And then I want to do an equilibrium problem. Did you guys run into one in the homework? Anybody yet? Did you have to do number 21 on page 517? No?
No. We did 20 or 23.
20 what?
20 or 23.
20 or 23. How about the next set of problems? What pages were they from?
545, 547.
545, 547. Okay. I'm going to find an equilibrium one. Look at number 21 on page 517. Page 517, number 21. So, I'm going to ask for help, so have your calculators handy, guys. You got a 23 Newton force acting at 60 degrees above the horizontal. So, 23 Newton force at 60 degrees. You have another 23 Newton force acting at 120 degrees. Okay, this one's going to be pretty easy. But 120 degrees would leave a 60-degree reference angle. What is the magnitude and direction of a third force that produces equilibrium? Okay? Equilibrium means the object ends up going nowhere. Okay? All the forces are acting on it in such a way that the object doesn't even move. They all act at the exact same time. The forces end up canceling each other out.
So wouldn't you have to do one in the third and fourth one?
Okay? Well, the best way to figure out what force you would need to cancel everything out is to figure out what these two add up to. Like, what would happen if these were the only two forces acting on the object? So let's find the resultant of these two. So, really this shouldn't take long. Help me with the x's and y's on these. They're going to be the same, FYI.
19.9.
For what? X or the y? 19.9. Agreed? 19.9 for the y. Okay. So 19.9, I won't write all my decimals. 19.9 for the y. How about the x?
11.5.
11.5.
That's okay. Exactly.
11.5. On this one, that x would be positive, but on that one, that x would be negative, right? Okay. Okay. So if I add them together, don't I get 0, 39.8 roughly? And I know I'm rounding that severely. There's a lot of decimal places, but I know I'm rounding that. So this is my resultant. Okay? This is what would happen to that object if these were the only two forces acting on it. I like to think of it as, again, if I would set this chair somewhere and somebody would end up pushing like that on the chair and somebody would push like that on the chair, this is what would happen, which basically means the chair ends up going where? Straight north, right? Okay? Which would make sense with that picture, because if you draw this vector, and then if you wanted to, from that point, if you would add that vector on using the picture, wouldn't it make sense that you'd get something that's straight north? Okay, so picture-wise that should make sense. So this is what would happen to that chair, okay, if these were the only two forces acting on it, yeah.
So is this kind of like number 15 on page 517 where it has the angles that would be
Me and Bailey had that set around yesterday.
Except in 15 they didn't ask for the equilibrium. But yes, those would be the exact, except they're different numbers too, the forces. But yeah, you just draw the two separately. Draw the two separately, find their x's and y's, add them together. Okay? So, what would this be in magnitude and direction, guys? What would this be in magnitude and direction? This is as an ordered pair. What would it be as magnitude? Don't think too hard here.
39.
0, 39.8 is just a vector that's 39.8 units long going straight north, right? So, it'd be 39.8 newtons of force
Straight north.
at 90 degrees, right? Or straight north, due north. So if this is the result of these two forces acting on the object, what force would you need to cancel everything out so this object doesn't even move?
A south force.
0, negative 39.8, or a 39.8 Newton force straight south, or at what angle? 270 degrees. Okay?
Would you say negative 90?
Negative 90, yes. Alright? Because if this is the resultant of the two vectors, and we want an equilibrium, we need to cancel this vector out. How do you cancel it out? Do its opposite. What's the opposite of 0, 39.8? 0, negative 39.8. Okay? So the equilibrium vector, the vector that puts it at equilibrium, would be 0, negative 39.8. Or in other words, 39.8 newtons of force at 270 degrees would be the third force to put on that chair. If we're thinking about the chair again, we're thinking about that object. If we have that as the third force acting on it, that chair doesn't even move. That's what equilibrium is. So if I were going to do an equilibrium problem, the two forces they give you, add them together, get that answer. Then, to get the answer for the vector that puts it at equilibrium, what would you have to do to this answer? It's what? It's opposite. It's exact opposite. So make them negative. 0 you can't make negative, so that just stays 0, but the opposite of 39.8 would be negative 39.8. So that would be the vector that puts it at equilibrium. That's that vector as an ordered pair. This is that vector using magnitude and direction. Okay? So definitely some equilibrium problems. You'll see. Okay, any questions on equilibrium? Okay, so I like the river problem. I like the equilibrium problem. Wanted to show those to you.